So hello, we are ready to start the session number 3, New Initiatives and Roadmaps for Future Success. I'm Fabio Pasiano of the National Institute of Astrophysics, Italian National Institute of Astrophysics, and I'm chairing the session with Andy Pollock, whom we all know. The first speaker of this session is Piero Benvenuti. I think we all know him. He's currently the General Secretary of the International Astronomical Union after having had a full career in ESA, leading IUE and STECF, and he has been the president of my own institution, so I had the privilege of working for him. And he has also been in the board of directors of ASI, so he's very an insider, definitely. So please, Piero.
Thank you, Fabio, and good morning, everybody. So why am I here? Well, I'm representing the International Astronomical Union, whose mission is to foster astronomy in all its aspects. So it's very interested in the initiative we are discussing today here. And also, I'm here, I think, because back in 1981, working with the International Ultraviolet Explorer, we started in our group in Villafranca the first uniform low dispersion archive of IAU, which was, the first example of public data offered to everybody to re-extract the information from this interesting UV spectra. And also, I think I reached an age which I can feel free to say what I think without any restriction. So that's an advantage. So this morning we listened to many very interesting theoretical talks about the impact that access to data can have sociologically and for the development of people. Now we see some practical implementation of what can be done. And I'm talking about this initiative of the IAU, which is called Astronomy for Development. It is, first of all, a very quick summary of what we are. It's almost 100 years that the union exists. We have more than 12,000 members from about 96 countries worldwide. And we, after the International Year of Astronomy in 2009, the experience that we had during that very successful year with all the initiative, we thought that astronomy has such a worldwide appeal that can be used to attract young generation to study science and exposed to technology, particularly in underdeveloped countries. So we developed a strategic plan which we implemented starting about 5 years ago. And the idea, as I said, is to use astronomy and therefore astronomy data to promote development, particularly in underdeveloped countries. So we started appointing a central office for the implementation of the strategic plan, which is hosted by the South African Astronomical Observatory in Cape Town. That is what we call the Office of Astronomy for Development. We very quickly find out that for an effective implementation of such a strategic plan, we couldn't manage the activity from a single office. We have to be very conscious about the local culture. We tend to, when we talk about advanced astronomical data and access to data, we always start from a point of view of a developed country that is used to use this data and have access to the information which is needed to make the best use of the data. The situation is very different in other regions of the world, and if you don't take into account the local culture in implementing such an initiative, you can be not so effective. And therefore, we decided to develop a number of regional nodes around the world. And we have now 9 such a regional node that you can see in this map here. Some of them has actually also the role of language node. And the main purpose of the language node is to translate the material that is produced by other nodes in worldwide, by the other data providers, into the local language, in particular Chinese, Portuguese, and Arabic. I mentioned this. I mean, you don't care about the structure of the OAD. What I think is important here is to see that this activity is done at 3 different levels. The so-called Task Force 1 is astronomy for university and research, so is an activity for high-level education. The Task Force 2 and the related activity is for children and schools. And the third one is astronomy for the public. So we cover these 3 levels, and this is what the regional node are doing and the language node are doing. As you can see here from the bottom line here, we are funding a project at a level of 100,000 euro per year. So this is peanuts for the other organization that this morning talk about theoretical implementation. They have much more money than what we have, but with this little money, we started doing something practical and effective. And these are the number of projects that we have funded. The demand is very high, and the money that we provide is really seed money. It's not really the amount that you can use for implementing a big project. But anyway, it shows that the demand for this type of project is very high, and we will continue to promote that, to fund them. Actually, we are now active in trying to get more money from sponsor. And this is the distribution of the project that has been done in the different areas, in the different level of activity, astronomy, university and research, schools, and the public. Actually, this activity has been, last year we got the Edinburgh Medal, which is a very prestigious medal in recognition of the activity of the group. So actually all the activity, particularly the activity devoted to astronomy, to university and research, is making a heavy use of the VO. And there was an AVO interoperational meeting in May last year in Cape Town, and this is the part of the presentation that has been made by the group, by the OAD office. So the advantage of accessing VO data for the different level, for schools, make a very valuable extracurricular activity. There is enhancing the potential to teach coding and data skills, so using the data. Keep in mind that we are using astronomy to develop skills. The goal is not to do astronomy. The goal is to implement new capabilities. So it's capability building. The fact that you can use real data and data obtained with the most sophisticated instrument, in particular the Space Telescope, are exciting. Is making the activity very exciting for people. And now, one of the problems which is being highlighted by those who are doing this is that to be effective in the use of VO data, you have to have a basic knowledge about astronomy and physics. So you cannot just use the data. You have to implement educational activity that make the effective use of the VO more useful. For university, this is obviously it's an extremely useful tool, because it put the possibility of people that do not have access to observing facilities directly to use first-class data to do their research. One, however, of the problem that has been found in the extensive use of VO is that, in a sense, you create, let me use this word, the illusion that you are entering big science very easily. If that, keep in mind that these people are working in countries that are a bit isolated, at least up to now. And so you are exposing this young student, very eager to learn and to do, with very sophisticated tools, and they can do immediately very good research. However, if they remain isolated, they can be frustrated later on because they couldn't proceed in their career effectively. So one of the components that we are now considering to put together with the use of VO is to create collaboration, strong collaboration with other universities, so that they don't only do their research locally, but they enter into larger collaboration. And that will be a more long-term effect of this activity. So, okay, I mean, this is quite obvious. Now, one thing that the OED is very keen in doing is to measure the effect of using this tool, in particular VO, on the development of the young population. And one thing that they are trying to do is to make a kind of blind test. We say you have school classes exposed to the use of VO and classes that do not being exposed to that, and then they measure their skills and development. So they're trying to actually measure the effect of the utilization of these tools. And of course, doing this large collaboration worldwide has also a very strong effect on peace and collaboration, eliminating barriers. This is something that the South African group is very keen on. So what they found in using the concept of the IVO Alliance is really the more than just the data, is the philosophy to make data widely accessible and to give that to anybody around the world. I just want to, when we talk about inclusion and data, I cannot avoid to mention this experiment that is being done by this astronomer Wanda Diaz, is from Venezuela. And she is blind, and she's doing astronomical research. And what she's doing is to convert digital data into sounds, and then to listen to the sounds. Now, of course, not all the data are equally adapted to this type of research, but she's insisting that blind people developed sensitivity that are not common to normal people that have all the senses. And so in some cases, by listening to the data transform into sound, they can get insight on some detail that would escape to the normal people. That is a very interesting talk. And she gave a presentation of this approach to a SET conference organized by Obama at the White House, and I strongly suggest you check that conference, that talk, because it's really very, very also moving. Okay, now the use of this data through the virtual observatory has created a lot of opportunities, and it's opportunities for collaboration with the Open Universe initiative. First of all, we have these regional offices that are placed in a very strategically interesting location. As you can see there, we have places, regional offices in Nigeria, in Zambia, in Jordan, in Armenia, in China, in Colombia, and these are working together. It is a real network. They are meeting regularly. They are checking what they're doing. They are exchanging experience. They share the difficulties that they encounter in approaching local people. Just as a very clear example of what I mean by that, the director of the OED is from South Africa and is a very energetic young researcher. He told me that when he was a boy, in his environment, young people were prohibited to look at the sky in the night because that would be bringing bad luck to the family. So that is the kind of culture that you have to consider when you talk about, accessing and transparency of the data. Together with transparency of the data, you have to take care of the local culture. Otherwise, our Western approach will not work. So that regional network, regional nodes network is a value already achieved and can be used as a test bed for what you want to implement with the open universe. So I think it's an offer, if you like, to collaborate with that. All what has been achieved can be used to tailor the development of open universe in the direction that you want, if this is the direction that we want to pursue. The other thing is that all this activity is sustained by a large number of volunteers coming from our union. So in addition to the regional node, there is this task force 1, 2, and 3 involve hundreds of volunteers around the world, which are very active, and they are keen in sharing their time to do this activity. So again, this is a kind of added value to collaborate on this project. So that is what I meant. I mean, now I'm talking about these 3 different levels in respect to what we would like to achieve with the open universe. There is the level of university, and we do have seen yesterday presentation of what has been done in the past 15 years about the attempt to make access to the space data and astronomical data in general easy. I think that we can summarize all that by saying that we achieved a standardization of approach. We set I mean, the AVO has defined a number of standards that can be used to make the data accessible, easily accessible. On top of that, we have seen also a couple of interesting implementation on top of the standards, one by the CDS, the other by the Canadian Data Center, which provide application based on the accessibility of the data. And I think that for the use by universities for research, I'm saying are good enough. Of course, you can improve that, but starting a new implementation from scratch, I don't think is a wise move.
No question on that.
For children at schools, I think we have seen some application implemented, which are good, but I think we need more. And there, really, we have to beat the language and cultural barriers. At the moment, the implementation that you see in CDS and in CAD is good for students that can manage at some point English, and they can access that, and they know what to do. If you go to schools, then you have to see that in many situations you will have to translate even just a basic thing in order to reach the population of people. And this is even more important if you want to approach the public. Not only the language there is important, but also the cultural challenge, as I mentioned before. It's useless to present, I'm not mentioning MS anymore, because I don't want to create another discussion like yesterday. This time I take the example of gravitational waves. Gravitational waves are detected and are very interesting, very important. If you don't teach people what space is in the context of general relativity, it's totally useless to show them data from gravitational waves. So you have to match the transparency of data, since this is the buzzword that we are saying all the time, with a cultural effect, educational effect. You have to educate people to the new science, to the new physics. Otherwise, you're just making cosmetic and interesting play with the data. If you want really to do citizen science, then you have to take care of the citizen culture. So I think my suggestion now, and this is my last slide. So what do we want to present to the UN delegates, in my opinion? This is my personal opinion after this, the presentation of yesterday. I think that what we must do is to present some, a selected presentation of successful AVO implementation. We are not starting from scratch. There is a lot of experience, a lot of it being done. We should build from there and not duplicate things. Of course, there is possible enhancement, and this has to be highlighted. If there are data which are still hidden and not reachable, that should be highlighted. Paolo said yesterday that 50% of the data are bitten. I'm not sure that that number is correct. It certainly is not applicable to large projects, because we know that. So, but nonetheless, if there are data which are not accessible and not enough transparent, that should be highlighted and we should implement that. Now, I think that I would strongly suggest to avoid any duplication of what has been done so far. If there is no obvious added value to what you want to implement. I think, on the contrary, what should be stressed is that the UN countries should support financially the best use of existing implementation. That is the key point. I mean, if you don't have the money to access computer and you have money to build groups of researchers using the data, then all the effort is lost. All this is now concerning research, university research. If you want to open the universe to the public and to the school, then there is a huge effort in education before you can talk about access to data. This will come naturally after, and it's there and it's ready. But the first thing you have to do is education effort, and that is very demanding. And when you talk about education, then you have to fight the language and cultural barrier. And my offer is to take advantage of the regional node network that we have implemented, if you think that is worthwhile to do it. Thank you.